Thank you, everyone. So this was a very impromptu talk, as impromptu as it could be. Like it was like an hour before that I said to Bastian, maybe I can do a talk because our regular the scheduled presenter was not feeling well. So yeah, you have to do with me. It's not a great talk, as I said, impromptu, and expect spelling mistakes and other mistakes. So yeah, it's fine. First of all, who am I? I don't see my slides there, so I'll have to keep doing this for your entertainment. Well, my name is Zeeshan Ali, and hopefully soon I'll have a new cooler last name, which is my actual last name. There's a whole new story. I can do another talk about why it's not on documents. But suffice it to say, is my father didn't put it in the documents for some reasons. So anyway, I submitted the application actually today to change my name to what it's supposed to be, because I'm expecting a son, and I want my son to have the proper last name. And also in Germany, you can get in a lot of trouble if you have a last name as Ali, because many Germans refuse to accept that as your name, and they say it can't be your last name, you must be wrong. So they correct it for you, and you get into a lot of fun trouble. So I don't want him to go through the same. Yes, and I've been have lived in many countries, and I'm a bit of a nomad. But I've been here for 5 years now, and let's see, maybe I'll stay here for long. Yeah, just another software engineer. And I've been into FOSS for a very long time, and did work on many levels of FOSS, well, Linux operating system and GNOME. I'm into flying. If you want to ever fly with me, let me know. I can take you for a ride above Berlin. It's really cool. I'm the creator and maintainer of ZBus, and all the rest I know is because of this project. I went through a lot of somehow this project ended up touching all the aspects, almost all the aspects of Rust, and it really tested the Rust language and my patience in turn. So I learned a lot because of that. Yeah, it's like, as I said, it's an impromptu talk. So I just thought like I will base it on something that I can already find. And I knew of this, something about the misconceptions, like a blog post from Kirill. Yeah, it's based on that, some of it. So just wanted to give the credit. So let's get to it. So first, starting with some misconceptions, like just two. And first of all is like this thing, right? Like when you are looking at an API, a public API especially, and it says this thing, T requires type, T is being a generic type, and it requires a static lifetime, everyone starts thinking, especially the beginners, that, oh no, this requires the type to be the actual type that you will pass to that function or whatever it is, to be around, the instance to be around for the entirety of the whole program, right? But that's not true. It's more usually the static lifetime requirements just means that it has to be around long enough to outlive or have the same lifetime as all the other lifetimes in that context. So it cannot be like, it cannot go away, like the thing you're passing, it cannot go away before all the other things around. I'm being vague, but yeah, if you play with lifetimes a bit, then you will realize what I'm talking about. So I'm sorry for the beginners here. And so there's an example, right? And this function is just generating a random string, basically. And that is saying, like, I'm returning a static string. But that string would not necessarily be around. It could be around for the entirety of the lifetime. It depends really on the caller. They can keep it around forever, and they can call it from the beginning of the program and keep it till the end of the main function. But they don't have to. And the reason is that it doesn't have to be kept around. And it just means that that the lifetime is not dependent on any of the in here. I'm not sure it's a very good example because there is no input parameters to this one, but if there were any, the return value would not depend on the lifetimes of the input values. For example, if it was taking a string reference here. So it just means that. So that's just a basic misconception, especially between beginners. And talking of lifetimes, many people think like they have been programming for a month or so, and they're like, okay, my program doesn't have lifetimes, and that's why I'm not get into trouble. And maybe I can just keep programming like this, and I will never have to deal with lifetimes ever. I'm sorry, but that's wrong. You will have to deal with lifetimes at some point. And the reason you have so far not dealt with lifetimes is because you have been lucky, and or you have done only simple stuff. Because there are always lifetimes. If you have a reference, especially around for anything, and str being the most common example, you will. It has a lifetime. It's just that Rust compiler is trying to be helpful, and it aligns lifetimes when it can for you, so you don't have to specify it, or you don't even have to see it. So this is an example for in here. Like you have a function that just takes a string, probably prints it, and in reality there is a lifetime, and the compiler would do something like that for you when it expands it for you. And similarly in the second example, it's like takes a string, gives a string, and they're supposed to have the same lifetime, and that's assumed when you have input and output, and it's assumed that the lifetimes are the same. So usually it depends on case to case, but usually it's a fair assumption by the compiler, and you will get an error usually when that happens, that the lifetimes are not correlated, and compiler assumes that, so you'll get an error, and then you have to specify the lifetimes specifically that it's not related. Now the interesting part that I wanted to talk about and because of which I thought I should do this talk, and that's like cows. I love cows, the real cows, and I love also the cows in Rust. And many people when they look at cow, also like the documentation doesn't do justice, so it's like it says copy on write, which is correct. It is a type that implements copy on write, but it's so much more than that, and it's so cool, and it helps you so much. It's more awesome than you think, right? So let's say this function, right? It takes a string again, and it takes a by reference, which is it's really good. It's like you cannot do it better. You don't need to keep the ownership. You don't need to take the string by ownership by value. So you just say, okay, just give me a reference to a string. I'll just print it, and that's the end of the story, right? You don't need to keep the string around or anything, and this is perfect. However, what if you need to keep the string around? What do you do then? You can still do it. Let's say we have a type keep str, and it keeps a string, and it has a constructor. It's a new function, and you just take the string. It has a lifetime, a string reference actually, and then you keep it around, and then you return that. But if you use that as a let's say this method is provided by library, and you are the user, and you're dealing with you want to keep keep str around, and you want to pass it around, and when you create it, you pass it a string, right, a reference, and now the lifetime of keep str is associated with the lifetime of the string that you passed to create it. And what if you don't want to keep that string around? You just want to keep str. What do you do then? So you're in trouble. And a lot of people, especially in the beginning, and it's valid in some ways, but I'll talk about the limitation later. And you say, keep, it can't outlive. So why don't you use string, which is valid? And I use it all the time as well. And it would be something like this. It's fine. The string you passed, it took its value, and it kept it in keep str and gave it back to you. Now the keep str doesn't have a lifetimes associated with anything else. It's completely independent. You can Actually, this has static static lifetime now, although you don't have to specify a lifetime anywhere, but this is an example of a static lifetime. Problem solved. Most definitely, the problem that we are going to solve, that is solved. But now you are forcing your caller, your user, to you're forcing allocation. You're forcing also possibly cloning. What if your type needs to clone and keep the string in another place? Then you're just forcing it on the caller, right? But what if the caller doesn't really want that, and they're okay with the first case that I showed? They were like, yeah, why don't you just take a reference and I will just assign it, static strings or whatever, and it will be all fine. And I don't have to do any allocation or cloning whatsoever. So how do we achieve this? And can we have both? Yes. That's where the cow comes in. It's a cow to the rescue. And how does that work? Wait. There you go. So instead of keeping the reference directly in your type, you keep a cow with the type. You specify the type of the borrowed thing, whatever you want to keep, and the lifetime. You just give it a lifetime, and it might look like, what's the difference? Like you might ask, what's the difference between the first example I showed, right, which was taking a reference and keeping a reference. The difference being is that you can now you can now create a cow from string, like a capital S string, like a allocated string, and you can pass it that, and then the keep str will have the S lifetime. It will become static lifetime in that case. So you can use it just like you used the previous example, right? There you go. So many slides between. Like this, you can use it exactly like this. You just have to create, say, cow colon from, and then give it the string that you were going to pass, and that's it. Where you go? There we go. Yeah, and how do you use it? Like this. Cow new. You can pass it string reference or like a string, allocated string, but you just have to do cow from, and that's it. And now you can have both, and you don't force your caller or your user to have allocation or cloning or anything, and they can use whichever kind of string they want. But we can do even better. We can use generics to our rescue. And then it makes it even better for your caller. Like it gets a bit, yeah, it's not so friendly looking the function anymore, at least for beginners. But once you have gone through a lot of Rust APIs, trust me, this is very normal. So and you just say that give me anything that I can convert into a cow str, and then the caller doesn't need to deal with cows at all. They can just pass directly a string reference or an allocated string, and that's it. And it's not limited to strings only. The examples I showed, like commonly you use it for strings, but it could be any type, or any reference type that implements two-owned trait, and then you can use it with that. Because when as the name of the type says, copy on write. So when you do clone, it will have to allocate. It will have to own it, and then it calls to owned, and then it becomes yeah, it needs that trait in essence. But like I mentioned, like this crate that I wrote, ZBus, a part of that is called Z variant, which is the encoding bit, like the low-level part of it, but it's available as a separate crate. And that one has a type called str. And as I said, like cow is very generic, so it can take any type that implements two-owned. But this type is specific to strings. So since it's specific to strings, it's even better because it's if you give it a static string, if you create it with a static string type, well, string literal as it's called, then it even when you say to owned, it will not clone. It will keep the original reference, which is because it has static lifetime, right? So it doesn't need to actually clone or copy, allocate or anything like that. So it's even a bit better. And you can do it the same way, like you don't want to use Z variant just for str because it has a lot more than just str. But you can have a look at the code, and you might want to use it for your code. Actually that's it from me, because as I said, this is very impromptu, so this is all I could come up with. But we can take some time to get some if you have some questions, or especially beginner level Rust questions, that's I can try to answer. And but before I finish off with this, I wanted to give a note for beginners, and that's like there's a really awesome, it's not long, it's a short blog post called Learning Rust Mindset and Expectations. If you are new to Rust, or if you talk to someone who are just starting up, especially coming from dynamic languages, JavaScript especially, tell them to read this first. Before you do anything, read this first, make sure you understand it fully. Otherwise, you will have some troubles that you can avoid just by reading this and understanding what it says. Yeah, that's it from me. Very short talk, I know. But
who wants to speak in the cube? No one? Any questions? Yes.
So what made you choose Rust for this, your project ZBus?
Oh, ZBus. No, actually it's the other way around, because I was writing some dbus, so dbus is a IPC protocol, very famous in Linux, and I needed to implement a dbus service, and there was only one crate at the time available. It was called dbus RS, and it's just a wrapper around a crappy C library. So I just couldn't figure it out. Also, it was because I was a beginner at that time, so that added to my frustration. And I was like, how about I just start a new one from scratch, which is purely written in Rust. And turns out it was hard, but ultimately I made it. So yeah, that's how I. So I had to do it in Rust because I needed it for Rust.
Okay.
More questions?
Any Rust questions? Like, if you have any problem with Rust, you are not alone. If you if you have a problem with Rust, you are definitely not alone. And maybe you are alone at this moment, but like everyone has been through that exact same thing at some point.
In that case, what was your background beforehand? And
so mostly C, and I did this weird language called Vala that you probably never heard of. Yeah, and then when Rust came along, I was like, wow, this is everything I have ever dreamt of. So and then I started writing Rust, and I realized this is shit because I just couldn't. That blog post I mentioned, that wasn't there at that time, and I just I was doing just shooting in the dark. But yeah, there were some people who helped me out, and then I realized I got it at some point. Yeah, now I get it. It's awesome, actually. I was not wrong.
Feel free to have a few more questions.
Okay, yeah. I wasn't expecting a background in C, because I was going to ask how you would recommend maybe teaching it, you were talking about more dynamic languages, if you had like maybe teams coming from that background, or because with C I can imagine there's a lot of things in Rust that would attract you, with
Right.
memory management and everything. So you get a bit of the more modern programming features, right?
Well, I think there is also, like, from other programming languages, there's like the safety is like on a completely different level, right? So if you care about safety, and not just in terms of like safety itself, right? Like you want to create a service, you want to create any solution that is used by users. You want it to not just break down at some random point because of silly null pointer dereference or something, which is very much possible even in high-level languages, many of them, well, actually most of them. So you don't want that. So that I think that's something. Safety is something that should attract people from all over, not just from low-level programming language.
Okay, another question. Thank you for stepping in.
Yeah, so since I asked about problems with Rust, I think async is fairly common concern among people.
Yeah.
So I was wondering, like, what's your personal take essentially? Because I see people taking different approaches. Someone would say, okay, I only do synchronous Rust, and then I don't have to deal with like 80% of the problems, and then I get 80% of the benefit. And like some people would say, no, you need to go all in, and then all your code is asynchronous, all your libraries is asynchronous. So I was wondering, like, what's your personal take? Because it's kind of becoming hard. Like, if you want to do synchronous Rest, but if you want to do any kind of networking HTTP clients, it's kind of like the whole ecosystem moving into async.
Right. Funny you ask, because I did some talks here about. I think I did 2 talks here about async. At least,
Sorry,
because the things that I mentioned, like that Zebus hit all the problems that it could, and one of the big one was async. So the first version of Zebus, it was completely blocking. It was synchronous, but it's more like an inter-process communication thing. So everybody was asking for when would you provide async, and the problem was that which runtime should we depend on, and if we depend on one runtime, then the other people are alienated. So I shot myself in the foot, and I said, okay, I will have a async agnostic, runtime agnostic library, and that was a pain, but I more or less succeeded. Anyway, to come to your question, well, basically, like it's the same thing that I learned from before I was introduced to Rust. If you are doing IPC, you are doing networking, anything that can potentially block, ideally you should be doing async. You should be using async await in Rust now. And I know that there's quite a few pain points still, but I think as an application developer, you don't have a lot of them actually. It's mostly smooth sailing nowadays, especially because as an application you can just choose a runtime. There's not a it's completely up to you, and most people choose Tokyo, and I wouldn't blame you if you do the same, because it's easier, and it's like they have this batteries included approach, so it has they have a lot of APIs, and they have also these most of their APIs feature gated, so you can disable everything that you don't need and only enable the things that you need, and that makes it super small as well. But there are use cases where you cannot use Tokyo, and some of them, like for example, embedded use case where you, for example, let's say you don't have an allocator even, and Tokyo is not currently, at least, it's not possible to use it. So you might need another runtime. What else? Yeah, and about Tokyo, it's awesome for application developers, but it's like they make it super easy for their own users, but at the cost of making it really, really painful for libraries that don't want to have a hard dependency on Tokyo. So and that was me. So I have a love-hate relationship with Tokyo. Does that answer your question?
Yeah, cool. Thanks.
Sorry, I went on a rant there.
Thank you. Maybe one more? No?
Nobody is as brave as that person.
Do you have a name yet for your son?
For my son? Yes, Jakub.
Okay.
Hopefully he will be Jakub Khan. We haven't decided the middle name. Middle name is like, I was saying Marian, but then you were talking Alexander. I don't know. We'll choose something.
Cool.
If you don't have any other questions, like, have you done a
Stop.
talk at one of the Rust
Yeah,
You have to say it again now. I'm sorry.
Yeah.
have you done a talk at one of the Rust Fests?
One of them, yes. Yeah.
Mm.
The last one, that one in Barcelona, Rust Fest.
Oh, right. Because I was pretty sure I seen you talk
Yeah,
before. Yeah.
That was me, yeah.
Cool.
All right.
Thank you so much.
You're welcome.